Welcome back. We've reached the coding part of the course, where we'll implement our interview tool prototype. To start off, you will need an IDE, Integrated Development Environment, which will serve as your coding toolkit. This helps you write, test, and debug your code all in one place. For this course, we'll use Visual Studio Code, or VS Code. VS Code is a great, lightweight, super flexible code editor that professionals widely use. Let's start with setting up the environment. If you don't have VS Code installed on your machine, go to the website code.visualstudio.com and choose the download option that matches your operating system. Wait for the exe file to download and then open it. To proceed, you must accept the terms and conditions. The default options are typically fine, but feel free to customize the installation. Once the process is complete, launch VS Code. You should be greeted with a welcome screen introducing you to the basics. Let me quickly walk you through the key points. On the left-hand side, you'll see the activity bar, where you can access your files, extensions, source control, debugging tools, and more. Right next to it is the Explorer, which is essentially your file navigation panel. You'll use this to manage and navigate through your project files. At the bottom, you'll find the terminal. If you can't see the terminal, navigate to Terminal in the menu in the upper left corner and select New Terminal. This is where we'll run our commands directly within VS Code, so you won't need to switch between the IDE and the command prompt. Finally, the central part of the screen is the editor, where we'll write and edit all of our code. Don't worry if it seems overwhelming initially. You'll get used to this layout quickly once we start coding. Next up, install Python if it's not already on your machine. To do so, go to the Python download page and download the latest version of Python. Select Add Python to Path during installation to simplify running Python from the command line. Then, follow the installation prompts to complete the setup. Alright, if you don't have Anaconda installed, let's go through the setup together. Open your browser again and navigate to anaconda.com/download. Click Skip Registration and download the installer that matches your operating system. Once the file has been downloaded, open it and follow the instructions. Make sure to install it for all users. During installation, you may see an option to add Anaconda to your path. It's generally a good idea to select this because it will make it easier to run Anaconda from the command line. If you don't select this option, don't worry, you can still add it manually after installation. If you already have Python and Anaconda installed on your machine, confirm their installation by opening the command prompt and running the following commands: python --version, conda --version. You're good to go if you see the version below for both. If not, you must add Python and conda to your environment variables. Once you have both VS Code and Python installed, we need to set up Python in the IDE. Open VS Code and navigate to the extensions view on the left side of the screen. Search for Microsoft's Python extension and click Install. This extension will provide debugging and linting. You might be familiar with the debugging process. It's simply searching for and correcting errors in your code. Linting is a less commonly known term for identifying potential errors, stylistic inconsistencies, and other similar issues. Now you know. Alright, we have Python up and running. What's next? If you haven't yet, navigate to the ribbon menu at the top and select a new terminal. A terminal will pop up at the bottom. Here, we run the command pip install Streamlit. This command installs Streamlit and all its dependencies. Now that we have it up and running, let's create a simple app to test it. Navigate to the File Explorer section of VS Code, and either click on the new file icon or right-click in the Explorer area. Then create a new file called app.py. In this file, write the following code. Import the Streamlit library and give st as an alias for easy reference. On the following line, invoke Streamlit's title method. Pass the string hello world as an argument. Now click Ctrl and S on the keyboard to save our changes to the file. Run the app by executing the following command in the terminal. Streamlit run app.py. This will start a Streamlit server, and a new window should automatically pop up in your browser, showing the app. If it doesn't, no worries. Open your browser and navigate to the URL localhost:8501. You'll see your Hello World app running. To stop the server, go to your terminal and press Ctrl+C. This will end the Streamlit process and free up your terminal for other commands. And here's a quick tip. If you need to rerun the same command, press the up arrow key in the terminal to bring up the previous command. No need to retype it. Great! We've successfully set up our environment and created our first Streamlit app. We're now ready to discuss Streamlit's most frequently used components. Let's dive in. Now you know that Streamlit is a robust Python framework designed for creating interactive data applications with minimal effort. Perfect for building prototypes. One of Streamlit's advantages is its ease of use, making it accessible even to those with limited web development knowledge. Those with technical aptitude are welcome to customize the app further using HTML and CSS, but the default Streamlit look will work perfectly well for our needs. Streamlit also offers a wide array of pre-built components, such as sliders, buttons, text inputs, and file uploaders, that make development quicker and easier. Additionally, Streamlit allows you to deploy your app easily and free of charge, simplifying the process of sharing your work. Another significant advantage is its ability to integrate seamlessly with popular Python libraries, such as Pandas, NumPy, and others, enabling you to leverage existing tools and workflows efficiently. Note that Streamlit has well-written and thorough documentation, where you can find examples and detailed information. Although we'll cover many of the framework's functionalities, it's highly recommended that you explore these resources to enhance your understanding and skills. A limitation of Streamlit is its limited customization options, which are restricted compared to traditional web development frameworks. For instance, while you can use HTML and CSS to enhance your app, you have limited control over layout and design. Streamlit's built-in components, like buttons and sliders, come with predefined styles that are not easily altered. This can make it challenging to create unique user interfaces or more sophisticated web applications that require advanced styling or functionality beyond what Streamlit's components offer. Performance can also be an issue, especially when dealing with larger datasets or complex computations. Streamlit apps might not perform as efficiently as applications built using more specialized frameworks for handling heavy data processing tasks, such as Django or Flask. Lastly, Streamlit might lack some advanced features that are available in other web frameworks. For example, it isn't as well suited for projects that require real-time data streaming, custom authentication systems, or complex database integrations. If your project needs highly specific functionalities, such as user roles, dynamic multi-page apps, or deep back-end integration, you might find the framework somewhat limiting compared to others. In the next lecture, we'll introduce some of the most commonly used elements in Streamlit. These elements will play a crucial role in building and enhancing our application. Alright, let's explore some of the most frequently used Streamlit elements, titles and buttons. We already have a Python source code file from the previous lesson called app.py, where we created an app containing only a title. Now, we'll modify this file to experiment with additional Streamlit elements. Let's continue the topic of titles, which, as you've seen, can be easily added using the available built-in functions. Let's change our title to "This is a title text." Once you've made the change, remember to save your file. Again, you can do this quickly by clicking Ctrl and S. Now, run the application. Recall we did this by typing Streamlit run and then the path to the source code file. In our case, that is app.py. We can simply press the up arrow to get the previous command and hit Enter to rerun it. The application opens in our default browser, and we see that the new text has indeed been included as a title. Nice! We can also change the text style, use emoji shortcodes, and modify the text and background colors like this. Here's what's happening. The underscores around the word this indicate italic formatting. The colons and square brackets are used to change the text color. In this case, a title will appear in blue. The colon specifies the color, and the square brackets contain the text that will be colored. Now, the last part of the string is an emoji shortcode. Streamlit supports many emojis, which we can access using shortcodes wrapped in colons. In our case, we're adding a speech balloon emoji at the end of the title. Apply this formatting to your code and save the file. Refresh the page where the app is open, and you'll see the updated title with the new styling. Nice! But there's more. Streamlit also supports LaTeX expressions. LaTeX is a typesetting system commonly used to display mathematical formulas and equations in a clean, professional format. Let's test it out and write Einstein's famous formula, E equals mc squared. As an argument to a title function, type E, followed by an equal sign, then mc, a caret, and a 2. In LaTeX, a caret indicates a power. To let Streamlit know we want this as a nicely formatted equation, wrap the body in $signs like so. Save the file, return to your browser, and refresh the page. Cool, right? Of course, Streamlit allows you to add headers and subheaders, and there are numerous ways to write simple text. You can use the st.header to create section titles and the st.subheader for subsections within your app. Let's save the file and refresh the browser page to see the changes in the app. Alright, we've got all titles, headers, and subtitles in place. In the next lesson, we'll explore the various text methods Streamlit offers. See you there. Now, when it comes to adding basic text, Streamlit offers 3 key methods: text, markdown, and write. Each serves a different purpose, and I'll walk you through how they work. First, we have text. This method displays plain, unformatted text, ideal for simple strings without styling. For example, we can write st.text and the sentence, "This is plain text with no formatting." Let's see how it looks in the app. As expected, it's a simple text with no formatting. Next is the markdown method, enabling you to create markdown syntax for adding formatting like headers, lists, bold text, and italics. For instance, if we write st.markdown and the following text, we're going to get a formatted sentence. In this case, the hash symbol creates a header, the double asterisks bold the text, and the dash makes a list item. You'll also notice a backslash and an N in the code, representing a new line. Finally, we have the write method, the most versatile of the 3. It can automatically detect and render different types of content, such as plain text, markdown, data frames, and even plots. This flexibility makes it the method we'll be using most frequently. And this is how it works. We type st.write and put the content inside quotation marks. Let's once again save the file and refresh the browser. Great! Of course, each element has its unique set of parameters. You don't need to remember them because they're well documented in Streamlit's API reference. Again, I encourage you to check it out and experiment with them throughout the course. Since write is the method we'll use most often, let me walk you through some of its parameters. As we've already mentioned, the beauty of the write method lies in its versatility. It automatically adapts to whatever you pass into it. We've shown an example of passing a simple string, but there's so much more we can do. For instance, we can pass a dictionary. Recall that a dictionary is a collection of key value pairs, often used to store data that needs to be displayed in a structured format. Here's how you can do it. First, initialize the dictionary by calling it data. Then, we'll give a name, age, and occupation. We then use st.write and pass data as an argument to show it. In this case, write will automatically format the dictionary into a neat table, displaying the key value pairs in an easy-to-read format. Streamlit also provides numerous interactive elements like buttons, text boxes, checkboxes, and many more. These elements make your app dynamic and user-friendly. We'll explore them in more detail as we progress through our project. But now, let's shift our focus to another important set of elements, the chat elements. See you in the next lesson. Streamlit's chat elements provide visually appealing, interactive components, such as input fields, messages, and specialized text. These elements will form the backbone of our interview experience, ensuring smooth and engaging interactions. Let's explore these, starting with the write stream method, which enables real-time display of text or data, creating an engaging typewriter effect like ChatGPT. It gradually reveals text or data as it becomes available. To use WriteStream, you must pass a generator or a stream-like object. Instead of providing a static string, you'll feed data into the function over time. Next, we have Chat Message, a function designed to simulate chat interactions within your Streamlit applications. This allows you to display messages in a chat-like format and supports both text and rich content, such as diagrams, images, and more, that you can integrate into your chat messages. Let's display a simple chat message. Use the following code. Start with the with keyword. It creates a context block that sets up a temporary environment for the code inside. Next, we call the stChatMessage function, adding user as an argument. This tells Streamlit to create a chat message labeled as user, which applies the appropriate styling to the message. We add the actual message inside the context block by typing stWrite and hello there. This line will display the text as the content of the chat message. But as mentioned, we can also pass other data types here, such as images and tables. You can customize the chat messages by changing the name or the role, which can be set as user, assistant, AI, human, or any supported string. Additionally, you can change the avatar, the icon next to the message, to an emoji, icon, or image, adding a personalized touch to your chat interface. Now, if we switch user to AI, save and refresh the page, you'll notice the icon next to the message changes as well. After creating the message, we use the write function to pass its actual content. In this example, we send the simple text, hello there. But as previously mentioned, we can also pass other data types here. The next element is the chat input, invoked with st.chatInput, which acts as a text box where users can type and submit responses. This function is essential for building chatbots and virtual assistants that rely on user interactions. We can create the chat input element by typing this code. On the first line, we create a chat input box with a placeholder text. Type your message. The content is stored in the variable prompt when the user types and submits a message. The second line checks if the user has typed something in the input box. If the input is filled in, the following code will be executed. Finally, we have the write function, which is responsible for displaying the message on the screen. Let's save the changes and refresh the code. Once we run it, we'll see our chat in action. Now, type hello in the text box. As you can see, the message is displayed as simple text. You can customize this element by limiting the number of characters a user can input. For instance, if we add a max characters parameter equal to 50 next to the placeholder text and refresh the application, a character limit appears in the right corner when you click on the text box and start typing. Alright everyone, these lessons taught us a lot, from creating basic components to displaying chat messages. In the next lesson, we'll explore another essential topic you must understand before building a Streamlit application: session states. Welcome back everyone! One important thing to understand about Streamlit is how it handles user interactions. Whenever you interact with any input element, like sliders, text fields, or dropdowns, and change their values, the entire Streamlit script reruns. That's right, dragging a date slider from March 1st to March 5th, or changing a dropdown menu from yes to no will execute the entire script from the beginning. This behavior is crucial because it explains how Streamlit updates your web app in real time, ensuring that any changes or interactions are immediately reflected in the application. This might sound inefficient, but Streamlit is designed to handle this smoothly. Still, this behavior can be confusing when managing interactions between multiple components. Let's explore a common challenge: nested buttons. In programming, nested means placing one element inside another. I'll guide you through an example to help us understand how these reruns affect our apps. We'll start by creating a new Python file. Let's name it example1.py. Now, let's walk through each step. First, we import Streamlit as usual. Next, let's set a title for the app. We can use the familiar function title and pass the string nested buttons example as an argument. Now, let's create the first button. We'll use the Streamlit button method, which returns true when clicked. By default, a button state is false until it's clicked. Once pressed, the state changes to true, which triggers the code inside the block. Based on that, we'll display some text with the help of the write function. In this case, the text revealed will appear upon pressing the button, changing its state to true. Okay! Navigate to the console and run the application by writing streamlit run example1.py. Observe what happens. When the button is clicked, Streamlit reruns the script, and since the first button now returns true, it displays the text revealed. So, everything works as expected. Let's now create a second button inside the first button's logic. I'll copy the previous code and paste it inside the first if statement. Let's change the button's text from first to second button. This means that this second button will only appear when the first button is clicked. Additionally, if clicked, it should display the message second button clicked. Let's save the file and test out the program. The script reruns by clicking the first button, revealing the text and the second button. However, when we click the second button, the script reruns yet again. This time, the first button resets to its default state, false, as if it was never clicked, causing both the text and the second button to disappear. So, we can never reveal the text second button clicked. How do we address this? Streamlit provides a system called session state. The session state acts like a memory bank for your app, allowing it to remember the status of components even when the script reruns. This way, your app can keep track of user interactions without losing information or resetting elements. Alright, let's dive into how we can fix our code using the session state. First, we need to initialize the state of each button using Streamlit's session state method. We can check whether specific keys are present in the session state. If not, we need to initialize them as false. Let's start by creating a session state called showSecondButton to control whether the second button should be displayed. We do this by writing if showSecondButton not in st.sessionState. st.sessionState.showSecondButton equals to false. This code checks if the Show Second Button state is already in Streamlit session state. If not, we set the state to false, meaning the second button is hidden by default. Now, let's modify our first button so that when clicked, it changes the state we've just initialized to true. Here's how we do that. Inside the first if statement, type st.sessionState.showSecondButton equal to true. Great! Now, we must check if the second show button state is true to determine if we should display the second button and accompanying text. To do this, we implement an if statement that checks the session state like so. When this condition is met, both the text revealed and the second button will appear. Inside the second button's if block, we'll display a new message if the button is clicked. Now, let's test our code. The session state show second button is false by default, so the second button is hidden initially. We click the first button, which sets our session state to true. The second button is shown, and the text reads revealed. When we click the second button, the script reruns, showing the text. But because we're using session state, the first button state is preserved. We can see that all the elements are displayed. Note that, since the second button doesn't have a session state yet, if we interact with other elements or click the first button again, the program will rerun, resetting the second button's click state. To fix this, we could also initialize a session state for the second button, but I'll leave that as a challenge for you to explore on your own. Good job, everyone! That lesson was challenging, but I hope you got the hang of it. In our next lesson, we'll start building our first chatbot. Let's keep going.